All right, so I went through everyone's proposal and kind of like left a comment and created, actually have a list where I've got, where is that? There it is. Every single person's kind of topic or kind of my thoughts or what data I'm going to look for you. So I've got a couple who got to me early. I've kind of got a couple data sets sent out. The rest of you, I'll kind of start working on them. So one thing that I'll talk a little bit more on Thursday is one way you could kind of start with your project is even if you don't have the data portion, kind of start building the lit review portion. And we'll look a little bit more at that on Thursday, talking about things like Google Scholar and kind of how you start building that, the kind of the intro and then the lit review. But I'll start kind of getting those out. Usually my goal is to try to get all of them sent out by the end of spring break. So over the next couple of weeks, I'll kind of work on gathering some of the data sets for those of you who kind of gave me a pretty good idea about what you want to do. And you should start kind of getting those emails. Also, double check the comment I left and don't just respond on Canvas. Send me an email if I had a question for you. So for some of you, kind of kept it broad, which is fine. And sometimes it makes sense if the data is pretty, I don't know if it's not very granular to like look across leagues, but for some of you, I kind of said, try to choose one league, just make it easier on you. Like it's kind of, you're trying to bite off a little more than you can chew. And so if I asked you a question there, email me the response of, what league, or if you want to do this as opposed to that. I try to clean up kind of some of your questions to make them a little bit more kind of precise and not as general. So look at those comments. I should, I started kind of working through some of the homework. So you should see the grades start popping up for those over the next couple of days. I said I wanted to have them all done before we start class Thursday. I'll be kind of close. So hopefully I can get all those done before Thursday, and I'll get the answer key up for that. And then you have that second homework that's currently out there. You can kind of start working on. I think someone came to my office yesterday and really you can get through like 4 of the 6 questions, and the last 2 we'll kind of cover throughout this week. Okay. Other than that, are there any kind of questions from you before we can jump into things here? Okay, so we left off talking about kind of measuring variation and kind of competitive balance. You can do this within season. I talked about kind of this idea of creating almost like an HHI for championships, right? Kind of share of all the championships over a certain time period that each team has won, adding those shares up. Kind of does a similar thing of like we use the HHI generally to measure market concentration. This would be a statistic that would measure, I guess, championship concentration, if you want to think about it that way. And the higher that value is just telling us that it's kind of more concentrated, right, within a smaller number of teams. So we would generally want to see these variation models if we're thinking about targeting, better competitive balance. We want to see these statistics be lower. So some other ways that we can maybe measure competitive balance, or thinking about, actually a couple of you had some good project ideas and thinking about like the makeup of teams and kind of like if you get a superstar versus kind of a more balanced team, that'd be the same idea here. You could use standard deviation measures in that. You could use variance measures. So that's what we're kind of doing here. We're just doing it not for a team, but we're doing it for the league itself. So I'm going to show you how to build these, and you probably hopefully remember them from 201, but there's something called Lorenz curve. So usually we use the Lorenz curve to measure income inequality, right? So you'll go through and you would, kind of look at the bottom 20% of individuals. What percent of overall wealth do they earn, right? And then you go to the next 20%, higher income earners. Okay, what percent of overall income do they earn, right? Then once you do that for each one of those, kind of usually we do it in quintiles, so 20% jumps. You could then have all of the X values, which would be the bottom 20%, then the bottom 40, the bottom 60, the bottom 80, the bottom 100%. That would include everyone. And then your y-axis, you would kind of have what percent of the overall income they earn. And you would just plot those points. So you can do the same exact thing for, I guess, not income inequality, but like win equality within a league, and kind of build a Lorenz curve. So I've got a little data set and I'll show you how to do that. But we go through and look at like, okay, rank the teams from highest number of wins to lowest number of wins. Now take the bottom 20% of teams and you can see, okay, they had 13% of all the wins in the league that year. Right? That will be your first point you plot. You could then do the bottom 40%, what percent they earn, the bottom 80. Once you have all those, I'll come back to this. Once you have all those points, You can barely see them here, but there's kind of all those 5 points and then just drawing lines in between them. This blue line would represent our Lorenz curve, where this kind of straight 45-degree line, right, running from 0, 0 up to 100 would be the ideal scenario. I guess not ideal necessarily, but would be like there's perfect equality. Every team has the exact same number of wins. So the bottom 20% of teams had 20% of all the wins. The bottom 40% of teams had the bottom 40%, so on and so forth. So we kind of, this line is kind of our comparison, right? This is like if things were perfectly equal. So kind of the ideal Lorenz curve, right, is if every team had a win percentage of exactly 50%, or kind of 500, the way that people generally talk about it, right? Every team would be winning half their games, losing half. We could then calculate these things like a Gini coefficient, although for here, it's gonna be a little different because it doesn't really tell us about the income inequality. It's just telling us about how far out of whack we are from like perfect competitive balance. Right? So the way that we get that coefficient is you just take the area under your Lorenz curve and you divide it by, well, usually we think about, you divide it by kind of the area under that line of perfect equality. But that line under that perfect equality, if we're doing it in percentages, that area will always be 50%, or will always kind of in decimal form be an area of 0.5. Right? So you kind of think about there would be like a triangle here, and I'll draw this out in the slides or on the dot cam in a second. So there'd be kind of this area under that line of perfect equality, and then you would just, that would be your denominator, and you would take the area under whatever your Lorenz curve was and kind of take that ratio. The closer that is to 1, that means the closer that we are to kind of this perfect equality measure. The closer we get to 0, right, the more and more unbalanced the league would be. So how do we actually do this? So I've got this data set that I put up on Canvas under the in-class or data in class, sorry. It's NFL win data. So if we take that NFL win data, I zoom in a little bit so we can see what we're doing. Not too much though, because I don't want to, there we go. So I've got a bunch of things I don't need here. I've got different metrics of the team. But really what I want to focus on is kind of the number of wins, right? So kind of best practices, we've already talked about this. If I've got some data, I don't really want to delete it. So the shortcut I use there, Control Shift or Command Shift on a Mac, hit over, hit the down arrow. That's going to select my entire data set. So I'm just going to copy. And I always kind of choose this values option, just keeps the formatting nice. You can see my teams. I don't really need anything other than kind of these wins, losses, and I guess technically here I need ties as well. Okay. So I'm going to get rid of everything here because I just don't need it. I'm then going to select the data I'm left with. Once again, Control Shift or Command Shift on a Mac, then use the over arrows, over and down arrow. If I go to this data tab, and when I send you guys your data for your project, I always try to turn this on before I send it. But if for some reason I forget, or you've gathered some data that you want to use, you go to this data tab and hit filter, right? It kind of creates this filter on the data to where I can now order this largest to smallest. And I can kind of see, right, what the highest win number or highest number of wins for a team was and kind of what the lowest number was. Okay? So I've now got them ranked. Well, in the NFL, it's a little bit easier because I've got 32 teams. So, right, when I'm breaking this down into my kind of quintiles, right, 20%, and think about what, 0.2 times 32, right? So the bottom 6.4 teams. So it doesn't work out quite as nice because it's not a nice kind of integer value, right? But I can think about kind of taking the bottom 6 teams, and I could, you don't have to necessarily plot the quintiles. Right, you could kind of break this down into something else. So maybe I want to do, oh, I don't know, the quartiles, right? So I kind of do the bottom 8 teams. And this isn't like, usually like I said, the typical Lorenz curve, we would kind of plot the quintiles, but since it doesn't work out to be a nice integer value here, and we are dealing with teams, we'll kind of change it. So now we'll just look at quartiles, right? So it'll still give us a somewhat of a Lorenz curve, but it's not, perfect in terms of being able to do quintiles. So we'll do something like this. So I've got my first quartile, or kind of, you can think about this as like the bottom 25%. Oops. I can then do my second quartile, which is really the bottom 50%. Go up to that third quartile, look at the bottom 75%, and then the fourth quartile, right? This is like all of the teams, right? The bottom 100% of teams. So all I'm going to do here is go through and say, okay, look, I know that first I just need to figure out how many total wins did the bottom 25% have. So I'm going to use this built-in sum function. This just adds numbers up for me in Excel. I'm going to go down here and select the wins for the 1, 2, 3, 4, 5, 6, 7, 8 lowest teams. I'll hit enter, right? I'm then going to do, okay, what's the number of wins for the bottom 50% of teams? So that should be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right, kind of getting those bottom 16 teams. Right. And then can do the sum function for, let me see. So 1, 2, 3, 4, 5, 6, 7, 8. So we'll start right here. This would be the bottom 75% of teams, or what? 24 teams. And then this one's pretty easy. Use that sum function, and we can find out what the total number of wins from all 100% of the teams was. Right? So these are going to be kind of the number of wins for each one of these quartiles, but I need to turn these into like what fraction of wins they have. So what should I divide this by? It's, yeah, just the total number of wins. Well, the total number of wins I know is down here, right? The bottom 100% of teams have 100% of the wins. So I'm just going to, I could freeze this. Actually, I'll do that for you because I don't think we've talked about that in this class yet. And you shouldn't have to do too much with this when you're working with your data. Mostly, I'm hoping, 99.9% of you are going to be able to do some type of regression analysis. But if you do want to start kind of adding some things up or kind of, dragging, copying, another trick in Excel is anytime I'm using these cell references, I can put $ in front of the column and row reference, and that freezes it. So when I'm copying it over, it will never change. Everything else, if I copy this over one column, it updates the column references by 1 everywhere I didn't use those $. If I copy it down one row, it updates the row reference by 1 row. Well, that helps me because when I copy this down, it'll grab the number of wins for each of these quartiles, but keep on just dividing by that cell reference, which is the total number of wins. Okay? So I can copy this down pretty quick. I could then take these, just insert kind of a line graph here real quick. And this really represents my Lorenz curve. And if I wanted to plot on there that line of perfect equality, so let's say I want that line of perfect equality. Here's my kind of Lorenz curve. What value should I use for that line of perfect equality? So if I'm thinking about this as the proportion, I could have also turned this into a percentage, right? I'll try to do that to make it a little bit easier. So if I've got a proportion I want to turn into a percent, I just move the decimal 2 places, or we can think about multiply by, 100. Okay. So I could do that instead. I get a weird graph while I'm doing this. There we go. All right. So what should the values be for this line of perfect equality? If I'm looking at the bottom 25, 50, 75, and 100%, what should those values be for my y-axis if I want this line of perfect equality? Yeah.
Just turn those percents into the whole number, or multiply those percents by 100. So 25, 50, 75.
Exactly, right? So I'm just going to use, if it was perfectly equal, every percentage I'm looking at would have that exact percent of wins, right? Because every team would have the exact same number of wins. So I could actually kind of create this column here. Now, if I grab this, insert my line graph. Oh, why doesn't it like that? Oh, you know what I should have? Yeah, I was going to say I need my point of 0, 0 here to plot. We can kind of grab these. And now I kind of get this nice, here's my Lorenz curve. And I didn't use labels here. I could use labels and make a prettier graph, but I'm just trying to kind of get the idea of how you would actually kind of generate this, right? You could play around with adding, different axis titles, things like that. Okay. Any questions over anything there? Okay, so you could do this for every single league if you really wanted to. You could do it across time and kind of look at every year, like what is that ratio, right? What is that Gini coefficient? So that's one thing you could do to use as a measure of like how balanced different leagues are if you do want to do some type of across league comparisons. So with this idea of kind of competitive balance, Another thing that comes up is this idea of the invariance principle, right? So the invariance principle is telling us that it doesn't matter who starts out with property rights, that the individual who ends up with that resource, or the company or the team in this specific case, right, will be the team or the individual who is willing to pay that resource the most. Our resource that we're generally thinking about, examples we're going to be thinking about will be players, right, labor. Okay, so the example would be, or we could also think about this in the ticket market first. I think I have a whole nother thing with players. So we've got, in a free and open market, whoever values the tickets the most would be the people willing to pay the most for them. However, if we have something like, perfect competition or a single price monopolist, we know that these tickets are going to be set, we're only going to have one price. Right? So we could think about in the ticket market, let's say, what do I want to get at here? So let's say we've got, even if we had a single price monopolist, let's say we are selling out. So here was kind of our supply or the capacity of the stadium, kind of set prices up here. And since marginal revenue is hitting that supply or that marginal cost curve, right here, we would choose that optimal quantity, go up the demand curve, that's the price we could charge. Now, the interesting thing here is if everyone's paying this price, there's some people up here who would have actually, right, demand reflects marginal benefit. So this consumer would have paid up to this amount, right? And this person would have paid up to that amount. Okay? So what would, let's think about a scenario. So there's enough demand to sell out the entire stadium, right? All of these individuals, if we think about the demand curve here, they're representing the marginal benefit of different individuals. Everyone here is going to pay above this price. So let's say we have a weird, I don't know, scenario or something where the radio doesn't really, I don't know if they still do this. I don't listen enough, but they used to give away tickets all the time. You call on the radio and you get tickets to games. So let's say for whatever reason that it just so happened to be that the person who won these tickets was this block of people down here. Right? So these people are given tickets to the game, which means maybe these people miss out, right? Because of, I don't know, like I said, they're giving away tickets on the radio or just a weird scenario, but let's just assume it for a second because it really helps kind of think about the invariance principle. What would all of these people do? Well, they were given the ticket for free, right? So the benefit to them is just wherever we're at in the demand curve. So if you offer them whatever the going rate is for that ticket, would they accept it, right? Well, if you think about it, if you're offering them whatever the price of the ticket is, that's now, once they own the ticket, that's going to be the benefit to them, right? So it's like if they sold the ticket to you, that price is the marginal benefit. And if we think about what's the cost to them, well, the cost is what they're giving up, which is how much they would have valued going to that game or using that ticket. So it's kind of weird, but right, their marginal benefit, once they own the ticket, now becomes the cost if they give it up, right? So they'd be willing to take that price because it's greater than their marginal benefit. So they sell the ticket, right? But what about everybody here who, because of this weird allocation process, didn't get the ticket before? Well, their benefit to attending the game, right? Their marginal benefit is the marginal benefit to attending the game. And if they purchase that ticket, the marginal cost to them would just be the price. But their marginal benefit is greater than that going rate for the ticket. So even if we start out with allocation of this resource, the allocation of these tickets going to people who don't value going to the game as much, if we have a free open secondary kind of ticket market where people can StubHub or whatever, you can buy and sell tickets, these people will find it advantageous to sell the ticket to the individuals who value it higher than whatever the going price is. So then who ends up with that resource? Who ends up with the tickets? The people who valued it higher anyways. So it doesn't matter if we did a first come, first serve, where some people might end up with it who didn't value it as much as others. If we have kind of this secondary market, we'll see that those tickets end up with whoever valued them the most, unless there's some transaction costs, right? So you can imagine a scenario where, let's say the person who gets the ticket down here, we'll say, and we'll kind of just use one person just to make it a little bit easier. So their marginal benefit is, I don't know, let's say they value it at $10, right? So this is the person who owns the ticket. And the marginal benefit of kind of the buyer, person looking to buy the ticket, let's say it was $30. Okay. And that the going kind of rate or the price of this ticket currently, oh, let's think about, I want to do something that makes a little more sense. So let's do, say it's 15, okay? Well, if there's no transaction cost, right? The person who owns the ticket says, well, look, if I sell it, I value that $15, I get $15, I only value the ticket at 10, so I'm actually net positive. Person buying it says, well, I value it at 30, I'm only paying 15, I'm also right, net positive, so they'll make that trade. Right? But what happens if they're using a secondary ticket market and every ticket sold there, they just charge a flat fee of $10, okay? What would happen in this scenario? Well, the kind of new benefit to the person who owns it, well, they're still getting 15, right? They don't get that fee. That's the third party that gets it. So they're still okay kind of making that trade, right? And the second person says, so they're not necessarily, actually, no, I think about it this way, my bad. So we've got the price is 15, they valued at 10, right? So they're net positive. But if there's this additional fee to use this outside source, well, they'll get to keep that $15, but then they'll pay the fee of 10, right? So they're actually only benefiting, if we think about like the net marginal benefit to selling the ticket, they're now only going to get to keep $5. What they gave up, they valued at 10, they're no longer going to choose to sell the ticket. So if you can get transaction costs or these kind of fees to use the outside third party, if they're high enough, then potentially this invariance principle breaks down and this person no longer sells the ticket to the person who values it more. Questions on kind of a little toy example, but you can kind of do even something more complicated if there's any questions. Yeah.
So would the fee be like that impact how much the buyer's paying at all?
Yeah, so think about it as only the seller, the person who owns the ticket, is going to have this fee to use in this outside platform. You could construct a different model maybe where like it allows the buyer to pay the fee, right? In which case, okay, if the buyer pays the fee, this person still wants to sell it. But let's say instead the fee was like, because the numbers I chose won't work. Let's say the fee was $20 and the buyer is the one who pays it. Well, now the buyer who values the ticket at 30, they're going to pay $15 for the ticket, but they also have to pay this additional fee, which is $20. So 35 would be the total cost, which would be greater than their total benefit. So it doesn't matter who you charge the fee per se. In this situation, it matters in that depending on who you, or sorry, it doesn't matter because whoever you charge the fee to, right, neither party would then choose to purchase it. You can imagine there might be ranges depending on how different the marginal benefits were from the price, that maybe the fee would prevent it from occurring on one side but not the other. But generally, right, it's going to break down no matter who you charge the fee to. It's going to break down that invariance principle to some degree, right? Varying degrees if you choose, different, to put it on different people. Any other questions on that before we keep moving? Shoot, I just got to pull this whole table up. So, we've kind of already done this, like think about a lottery or a radio station doing that. And then kind of we discussed like if you had transaction costs, potentially this could break down. Okay. So let's think about this more so in the context of the labor market, right? Because there's some pretty interesting things we can kind of dive into. I don't know if we'll get to talking about necessarily the draft today, but the invariance principle directly applies to kind of teams obtaining different players or different quality players. So let's say we had free agency, right? So players are able to sign deals, pursue contracts with anyone they want, right? We don't have a reserve clause or anything like that. Once they're in free agency, right, they can just go out, talk to teams. And if all they care about is money, which let's just assume that for a second. We can kind of add more things to the model here in a little bit, but let's just assume all they care about is signing the largest contract. Right? Who's going to be able to offer them the largest contract? Or who's going to be able and willing to offer them the highest contract? So if we simply just think about the labor market, and we started looking at this a little bit last week. So if I've got the market, and let's just say my quantity of labor, I've got my wage here. And we're only thinking about one player now. So there's going to be some marginal costs, right, to supplying that labor. Or think about that supply for labor curve, right? Supply always represents marginal costs and demand represents marginal benefits. The teams that are out there, I don't know why I'm trying to use different colors. The teams that are out there, maybe one team, right, already has, we could think about maybe the market for a top level quarterback. Maybe this team already has a top level quarterback. You know, it would be a minimal improvement to add this, you know, whoever this free agent is. And so we'll kind of call this the demand for team one. They'd be willing to pay that player whatever that equilibrium wage would be. And let's just assume no monopoly or monopsony power just to kind of simplify this. But maybe there's a second team out there and this player, right, same quality player, they don't have, you know, currently have a high quality, they currently have a low quality quarterback. And so adding this player would add a ton of value to the team, increase revenues a lot. Maybe even it's not just, do I have a quarterback? Or maybe it's small and large market. The same player playing in a large market can command more, or, you know, generate more revenue. So that demand curve is going to be higher. That's the team that would be willing to pay that player a little bit higher of a wage. So if we think about the player's decision, when they're dealing with all these different teams, really whoever has the highest demand curve, right? Who's going to benefit the most from adding that player? That's the team that would be willing to pay that player the highest wage. And so we kind of think about with free agency, who gets that player? Well, it's the team that values them the most. Is that making sense? Are any questions on that? And it's just purely driven off of kind of who, you know, who's going to generate more revenue from adding this player. Right? And if you wanted to, you could like complicate this model and think about, well, it's not just wages. Maybe what I want to measure here is really for the player kind of utility, right? So it'd be like some measure of like salary plus like living condition. I know maybe they have preferences for different cities or something like that, but it would really operate the same way. Excuse me, right? They're just going to choose whatever they value the highest, right? Whether, and you know, the team that would be willing to offer them the most would be a team that values them the highest. So even if it's not just wages that they offer, maybe they offer them wages and I don't know, a promise of like stake in the team, or I don't, you know, they offer them these other kind of intangibles. Then maybe we see not just wages being the ultimate factor, but it's really the total utility. But we have the same idea. Okay. So with free agency, this player ends up on the team who values him the most. But what if we don't have free agency, right? Let's think about, we have zero transaction costs for a second, okay? So trading a player, right, it's not like I have to pay a huge fee if I trade them. So what's going to happen? It's the same thing as what we do with the ticket market. It's just going to go back to, there's a demand curve. And if we think about that demand curve reflecting the marginal benefit, and now, you know, get rid of the ticket market, but we're just thinking about the marginal benefit of adding that player. Well, even if the team that ends up with the player is down here, they'll sell it to the team, or they'll trade that player to the team who values them the most, because, right, how much would I be willing to give up for that player? Well, it's really going to be however much they benefit me. So let's think about, I'll do another graph here. So let's think about, actually, I'll just use a numerical example. I think that'll make the point here a little bit better. So let's say there's a team. So we'll do team one, team two. Team one currently has the player, and their marginal benefit from having that player in the team, you know, if we could put this into some dollar amounts, maybe this is in millions, but like, let's think about it as like $10 million. The second team values that player a lot higher, right? Maybe like they're lacking in that position, they're in a larger market, and maybe they'd be willing to pay that player up to 20 million. But we've got this idea, it's not in free agency. Team one has the rights to that player right now, right? Maybe the contract's not up yet. Okay. So we think about how much, let's say this team was actually making a good decision, and we think about the salary or the marginal cost or the wage they were paying the player. they paid them exactly how much they valued it, right? So somehow in the past, they were making the optimal decision. They paid the player exactly the salary that, they increased that team's revenues by. Team 2 looked at this and says, well, look, we'll easily take on that $10 million of salary, right? If we make a trade with you, like if all we give up is like, let's say just straight cash of $10 million, team 1 would be indifferent at that point. So maybe team 2 offers 11 million. 11 million is better than the current marginal benefit. So they give up that player, take the $11 million, right? Yeah, they no longer get the benefit of having the player, but they've got an additional $11 million net benefit there being $1 million. Right? This team is going to say, okay, look, we would pay you 11, or maybe team 1 knows team 2 really needs this player. Right? So they kind of bargain going back and forth. Team 1 could actually get team 2 to pay up to how much for that player? Yeah, if team 2's marginal benefit is 20 million, they'd be willing to pay team 1 up to $20 million, right? So maybe they take on the salary, right? Because the salary is they're taking that $10 million off of team 1's hands and then give them an additional 10 million, right? So we know that team 2, if they value them higher, will always be willing to kind of pay a higher price than team 1 can kind of resist, right? It's always going to be a value that's greater than team 1's marginal benefit. Now, the same sort of idea with the ticket market, this breaks down if we have really high transaction costs, right? So what would the transaction cost be when we think about kind of trading players, right? So it doesn't matter here, whatever team values that player the most, it doesn't matter if the player starts out in free agency, no one has rights to that player, or they start out with a different team, right? If we allow for trades, right, and there's zero transaction costs, we'll always end up with the team who values a player the most is the one who ends up with that player, okay? So what would transaction costs and reserve clause still allowed for traders to be played? So one thing to kind of bring up that relates to what we talked about last week is, so the reserve clause is really just no free agency, right? The teams always had the rights, even after the contract was up, they had to trade away the rights to the player. So what still led to players ending up on the teams that value them the most, it's just that instead of the players getting that additional money or increase in wages, it's the teams would pocket it, right? In the scenario I was just describing where there's a trade, they're not going to give an additional $10 million to the player that they're trading. They're giving an additional $10 million to the team they're trading with. So really all the reserve clause did, it didn't break down the invariance principle. It just took some of what would have been producer surplus, right? The players are supplying the labor, and changed it to consumer surplus, right? Or gave surplus to the teams. So we already talked about these transaction costs. So one of them that can break this down is if I do have a cap, like a salary cap, where if you go over, you have to pay an additional luxury tax. We can think of taxes would also be transaction costs, right? So if I add these luxury taxes, why doesn't, I'll give a good example here. So we think about Major League Baseball is not great because they don't have a cap. Let's think about the NBA, right? Why doesn't one team, why doesn't LA or New York end up with the 5 best players in the league? Well, because at some point they have to start paying additional money, right? Once they go over the salary cap, right? They have to pay this additional luxury tax. And now when they're thinking about trading with teams, well, now they have to pay this additional amount. It was just like that fixed fee when we were thinking about tickets, right? And if that fee got large enough, or that luxury tax got large enough, it no longer, right, is a net positive value to trade for that player. So luxury taxes could break this down. I think here maybe I have it, but just dealing with, if you think about dealing with agents, the percents they take when we're thinking about trades, potentially that's an increased cost as well. Now it's likely those don't ever get large enough to really severely break down the invariance principle. It'd probably be more likely something like a luxury tax would. Well, you could imagine any other additional type of cost that is related to a trade occurring could break down the invariance principle here. Is that making sense? Some questions on that? So we've kind of already talked about revenue sharing. I jumped the gun at an earlier, earlier topic, but we've talked about all this. So we'll review it real quick and then I'll introduce some new stuff to it. So we talked about, big market teams, right? Even if they pay the same percent, they're going to see a larger shift downward in their demand and marginal revenue curves. We've talked about, some of the questions on your homeworks even are thinking about, okay, if teams are win versus profit maximizing, how does revenue sharing impact them? If they're profit maximizing, they just pocket the revenue, right? And don't increase their wins at all. We see a larger shift in the demand and marginal revenue curve for large market teams. So maybe revenue sharing does kind of bring the optimum of wins a little bit closer together. But right, if they're profit maximizing, all bets are off because they might just pocket the money. So these are all things we've kind of looked at. Okay, so if we think about, specifically, we'll think about a scenario where we have a win maximizing team. They're just spending money until they get to the profit, where their profits are equal to zero. Right? So they're spending more money on talent. And if we had a league where we had maybe half, let's say market size was the same across every team, but half of them were win maximizing, half were profit maximizing. So we have this gap in the wins for those two teams. And we want to kind of improve the competitive balance in our league. How might we be able to do this, right? How can we bring those kind of targeted number of wins from these teams a little bit closer together? Okay. So we can do things like salary caps or salary expenditures. Okay. So we'll go through where we have, there's no variation in market size, and I'll kind of try to walk through what revenue sharing is and kind of how we could impose like salary expenditure minimums or maximums. So let's see if my blue marker works. I'll change the color up a little bit here. Stand out a little bit. All right, so we've got wins, dollar amount associated with each one. We'll keep marginal cost constant just to kind of simplify this model for a little bit. And then we're thinking about there's no variation in market size. So every team is facing the exact same demand and marginal revenue curves in the win market. Right? No variation in market size or anything. The amount of revenue from each win is the same across every team. So we've got profit maximizing and win maximizing teams. How can I bring these closer together? Well, if I have some idea as the league about what amount of money on salaries would have to be spent in order to obtain different levels of wins, then I could start to essentially each one of these wins really translates to a total amount of money spent on players. Right? So if I think about, I can come up with a dollar amount that would translate to this number of wins, right? So I think about this is like a salary for, I guess we'll call this W star, right? So whatever number of wins this is, this would be like the salary that translates that. You can also imagine like there could be a function, right? Function of X is equal to this, or some specific number. Here, my function is this salary function. My variable X is just the targeted number of wins, right? So the league could kind of try to come up with the salary that's associated with this number of wins and say, okay, here's the salary cap for the league. We're not going to allow teams to spend anywhere past whatever value this translates to. Right? Now that salary amount will kind of be, correspond to whatever targeted number of wins the league wants, to kind of put a cap on, right? And hopefully, if they've done this correctly, this number of wins will be below whatever the win maximizing teams are choosing. If that's the case, well, the team's decision here, okay, I'm going to keep winning, I'm going to keep winning, I'm going to keep spending more money. I'm going to win maximize all the way until profits are equal to zero. But I hit this point, if I want to target a higher number of wins, I can't spend any more money on players, right? Now, maybe I can still get to that point if increasing wins doesn't depend on my players' quality. Like maybe I could spend money on my coach, or maybe I could spend money on, I don't know, athletic training, right? But I mean, I think you'd find it hard pressed. And if you look at, we'll start talking about like the marginal number of wins that players add, or the marginal number of wins that a player or a coach would add. Any of the kind of academic research I've looked at, I mean, the effect of player quality is vastly outweighs anything else, right? There are other things that you could kind of spend money on, right? If you still haven't hit that profits equal to zero and maybe increase quality, but really the primary driver is going to be salary, right? Or player expenditures. Okay. Does this make sense? Are there any questions on this? So, in this scenario, yeah.
So could you explain it again?
Mhm.
The y-axis is for profit, right?
Yeah, so I wouldn't think about it as profit, right? Because we've only graphed marginal cost, marginal revenue. So you can think about it as it's really just measuring dollars, right? So when I go up, if I'm at this number of wins, my marginal revenue and marginal cost would be some dollar amount. But if I'm over here, my marginal cost is this dollar amount, but my marginal revenue for this number of wins is going to be somewhere down here. We don't have like total revenue or total costs anywhere on this graph, right? Now you could go and kind of put all of them up there. But don't think about it. This is where it does get tricky because salary is also in dollars. But the idea of setting these salary caps, it's not like we're choosing a dollar amount here. It's almost like there's a separate graph that we would need, right? Which is here's salary, expenditures, and here's numbers of wins, right? So every single number of wins we could map down here, and maybe there's like let me think about, right? It should be increasing, right? As I spend, or as I want to target a higher number of wins, I got to spend more on my player's salary. So whatever number of wins this would translate to, this is the salary cap I would select. So it's like there's another relationship on a completely separate, it's not even really a market per se, but a completely different scenario. Like here we're looking at the market, here we're just looking at the relationship between targeted wins and salary expenditure. And from that relationship, probably what the league does, I mean, what they should do if they don't do this, is they could look back at historical data and really like you would just have all these teams, how much money they were spending on player salaries and how many wins they ended up with. That would give you could do some linear regression. You get an idea about what that slope coefficient is. What's the relationship between wins and salary expenditures? And then from that, you can kind of set a salary cap expenditure that translates to a certain targeted number of wins that you believe is below what your win maximizing teams are doing. Other questions on that? Those are a good question because this is tricky, and the way you asked it made me think of this. Okay, so I think I've got a couple other blank slides. It doesn't really matter even if they're profit maximizing. So let's imagine a scenario where we have differences in market size. Okay? So I might have a large and a small market team. Excuse me, we'll keep marginal cost the same between the two and constant to simplify. Here's my small market. Here's my large market team. Right? So the other one we just looked at is kind of naive, right? We didn't have any variation in market size. So what if we do have variation in market size? Okay, let's assume that both teams are profit maximizing. Okay, so profit maximizing point, the targeted number of wins would be wherever the marginal revenue is equal to the marginal cost. And that's going to be at two different points for the small and large market teams. So we've got this gap in wins. We've got some, imbalance in the league that's caused by differences in market size. So how can I use salary caps to help with this scenario? So even if they're not win maximizing, and that I just know that there's some imbalance because of market size, I can do the same exact thing, right? I could say, hey, look, whatever this number of wins is, I'm going to set a salary cap that I believe translates to that number of wins. Now the profit maximizing teams in the large market, right, once they get up to this point, they're restricted to, they can't spend any additional money on their players, right? So they can't improve player quality, they can't improve the quality of their team, and kind of their targeted number of wins is going to be, right, whenever they spend up to this salary cap like amount. Okay? So even with profit maximization, using salary caps can help us kind of reduce that competitive imbalance, right? We're going from a gap this large to a little bit less. Okay? And this isn't I would argue this isn't even a real perfect model or measure of how much that gap will close, because if they're targeting a lower number of wins, so remember, these are, I think starting out, I kind of mentioned, these are always going to be like targeted number of wins. The issue is like, if I'm targeting a lower number of wins, then I have to see like, what are the outcomes actually, like, how does it play out? What are the actual outcomes? I know that each team, let's say every team in the league in the NFL was targeting 2 wins out of 17. Well, not every team's going to end with 2 wins, because a team has to win, a team has to, I guess, maybe technically if they all played for ties, maybe we get something weird there. But the idea is that if I'm targeting a lower number of wins, maybe the actual outcomes is that even though small market teams were targeting a low number of wins, they end up winning a few more games because now the large market team behavior has changed a little bit because of the salary cap. So it's not perfectly capturing it, but it is giving us that indicator that that gap is going to close. Okay. What if, and how does this salary cap impact the small market team? Yeah, someone's going, it doesn't, right? They're spending an amount of money that translates to a much lower number of wins. And because we know that relationship between salary expenditures and wins is likely kind of this line of best fit has a positive slope, right? We know that they're spending an amount lower than whatever the salary cap is. What if I wanted to do something like, maybe I look at the large market teams here and I'm like, well, I don't really want to restrict their expenditures. Like they're generating, if they choose this target, they're generating more revenue for the league. Like this is a good thing. So instead of kind of hamstringing the large market teams, what's something else maybe I could do is say that, well, look, we're, we could look at this, look at the league and say, a lot of your current revenue. So let's say that the small market teams are profit maximized. And we know that the point where their profits are equal to 0 is going to be somewhere out here. So the league looks at them and says, well, look, we know that we're sharing all this revenue with you. So maybe we even go to the scenario where we've got revenue sharing. And maybe we know that they could spend out to this point, right? Where profits be equal to 0. So the league says, okay, the small market teams, it looks like they're profit maximizing. We're looking at their, their recorded profits, and they're just pocketing this money. So what can we do? Well, we can at least tie the revenue that we're giving them and say a certain percent has to be spent on player salaries. Or I could look at this and say, well, look, I know that their bench players are really, really bad, right? And that if we force them to pay their kind of the salary minimum in the league to be higher, they're going to go out and really make sure that they're paying a higher cost. They make sure they're also getting a higher quality player. And so we could set a salary kind of minimum, right? That would translate to a higher number of wins. Now this team, yeah, they would like to target this number of wins, but they're almost forced to spend additional money on their player talent, right? Or spend additional money on players, right? And if they're going to have to spend the money, they might as well try to spend it optimally, right? And increase get the best quality players out there. So really, we're just kind of putting bands on the maximums and minimums on how much they can spend, which will translate to certain targeted number of wins. So I don't have to necessarily target my large market teams. I could target my small market teams with salary expenditure minimums. Okay. There we go. Okay. Any questions on this? You have one more interesting point to make here. What happens if I guess wrong, though? What happens if the league guesses wrong and they try to set a salary minimum up here? What's the issue with that? Yeah, right. I push those teams past the profit equal to 0 point. If I set salary expenditures high enough, like the minimum high enough, I potentially could drive teams out of my league. right? So, maybe that is one advantage to using salary cap maximums as opposed to minimums, right? I'm not going to drive anybody out of the league by putting salary cap maximums there. All right. Any questions on this before we keep moving here? Okay with this? All right, so we've got salary caps, and this is just some more kind of, we've seen how they would work, but it varies across leagues. So, the NFL and NHL have upper limits. The NFL actually has a lower limit as well. So notice like there's a pretty narrow band of values where like you have to have salary expenditures somewhere in that range. And then the NBA, theirs is just like an absolute mess. So they don't have a absolute like team minimum. I think they have a player minimum, but not a team minimum. But they've got like luxury taxes. Or actually, sorry, maybe I'm wrong about this. Soft cap. Let me think if I can remember from off the top of my head. We can Google it, but I believe. Okay, so they do have a lower limit. For some reason, I thought they didn't. So you have to spend at least $84 million on player salaries. If you spend over 94, you have to start paying a certain luxury tax, but certain players are exempt. It's really complicated. Like I think I don't know when we'll discuss it. Is it here on the next slide? Yeah, it is. Okay. So they've got a bunch of different exceptions where those player salaries don't count against the cap. And even after you go over that $94 million limit, you can spend, right? You can keep spending money past that point. You just have to pay the luxury tax. But even once you get to $113 million, they say, we're not even going to give you the option of paying luxury tax anymore. You can't spend past this point. So a little bit more complicated. And then the great MLB, which just makes for like interesting, you can answer a lot of interesting questions with this, comparing Major League Baseball to other professional leagues, because they have no cap, right? So given these caps, what league would you expect to have the biggest issue with market size? So what did salary cap maximums and minimums do? They kind of hamstrung the large market teams and kind of forced the small market teams to spend a little bit more. So which of these leagues would you expect there to be the biggest gap between large and small market teams? Yeah, Major League Baseball, they are not using anything, right? So, the demand curve for large market teams could be insanely higher, and that justifies them spending a lot more money, targeting a lot higher number of wins. And so if you did like a cross league comparison, and just looked at, the standard deviation or the variance measure in terms of wins, I would imagine, I would go out on a limb without even seeing the data that Major League Baseball's is going to be much, much higher, right? In terms of the variation that we see as a result of market size. Any questions on this for keep moving? So I have all the details here. I'm not going to take a lot of time to go through each one individually, but there's all these exceptions. So the NBA has this real, it's not a hard salary cap. They do have that hard salary cap of 113 million, but between 113 and 94, right, that was where I had to pay some additional luxury taxes. But I don't even have to pay those luxury taxes if I don't go over 94 million. And the league has started to create these exceptions that say, look, if you're paying this player and they fit in this category, their salary actually doesn't count against that salary cap maximum. So there's things like, you've got one player, you can sign at the league average. So let's say I'm currently spending $93.99 million, but like I need to fill out one more spot in my roster, right? And I look at this, I'm like, well, I can't sign someone for $1, right? I'm gonna have to spend like at least a couple $100,000. I don't know what the lowest salary in the NBA is, but my guess is it's somewhere on there. I might be way off, might be higher than that. So let's say the lowest I can pay a player is $1 million. Well, that would push me over the salary cap. So how do I fill out this last roster spot? Well, the league says, okay, you can sign one player if they're at league average or below, and they won't count against your salary cap. So a lot of teams will use this exemption so that one of the people on their teams doesn't count against their salary cap. Right? Then there's like rookie exceptions. So now we throw all these. So the rookie, if they're signed to their first contract and it pushes the team over, you don't have to pay the luxury tax, right? You can use that exemption. You've got another exemption, which is Larry Bird, which is that you can re-sign a player if they were currently on your roster, and that won't count against the salary cap. I won't push you over the limit. They've got these are arguably they're not named this, but basically you saw this be created because of these two players. One, which is that if you have a player and they're in their rookie contract for the 5th year, you actually if they win like different awards. So I don't think it's just MVP. They meet criteria. Oh, including, okay, so this one they had to win the MVP. Oh yeah, the next one is you could win a bunch of different awards. But if players meet these certain criteria, you don't have to count them against your salary cap as either. So what are all these things trying to do, right? I mean, maybe with the exception of the mid-level, is they're trying to ensure that teams that end up with a good player, right, can continue to keep that high quality player, right? And one way that they can guarantee that is that that team isn't going to have to pay an additional luxury tax by keeping them. So the goal of a lot of these exceptions is to try to improve competitive balance, to guarantee teams that are getting these, high quality rookies, if they're trying to re-sign a player that was already high quality, right? They even say like they have to have these awards. They're trying to guarantee that those teams can keep them. This wasn't created for the large market teams, right? They're going to be able to probably pay those players most anyway. So this is really kind of created to protect and help small market teams be able to kind of retain high quality players without paying additional costs of like the luxury tax by going over these salary caps. Okay. What are some other things they have? Oh, so this is kind of interesting to think about with the models that we've looked at. So the NBA has not only team kind of taxes, but they also have player taxes. But if we think about specifically kind of these team level, right? So I can't spend more than $100 million or whatever it was on total on my player salaries. And if I start to go over, I'm going to have to pay an additional amount. So if I go between $0 and $5 million over that hard or that soft cap of, I think it was 93 or 94 million, for every additional dollar I spend in that range, I'm going to have to pay $1.50. So it's almost like a 50-cent tax, right? So I'm not just paying $1 for every dollar, I'm spending $1.50, and then $1.75 if I go a little bit higher over that, et cetera, et cetera. Okay. And if I repeat this year after year, they're just going to increase that tax that I have to pay. Okay. So what this is going to do is essentially, if we think about that every unit of talent, and this isn't a wild assumption, but it's a little bit difficult. If every unit of talent had the exact same cost, so this was the idea that, even if I sign a player, they may possess higher amounts of talent, and so I can pay them more, but per unit of talent, I'm paying the same dollar amount. Okay? So we've got this constant marginal cost. Let's say we've got this large market team, and we'll just kind of focus on that. So here's their marginal revenue, here's their demand. And let's say that they are kind of win maximizing. That's the scenario that we start out with. We'll call this scenario one. If I then institute this luxury tax that as teams target a higher number of wins, eventually there's going to be a number of wins that translates to a certain amount of dollars spent on player salaries. So maybe let's say this number of wins is where I hit that soft cap. And now if I want to target a higher number of wins, now for every unit of talent, essentially, right, or every dollar I spend on player salaries, I have to now pay $1.50, right? Or which, depends on, what league we're looking at. But the one the table I just showed you, we go from paying $1 per unit of talent to $1.50. So now if I want to spend additional amount, it's almost like my marginal cost curve is now higher. So we'll call this marginal cost 2. This is our original marginal cost curve. So we'll even just do why did I put 3? Marginal cost 1. So we'll even just do the most simplistic, which is like, let's assume that it's not like the NBA where there's these different bands. Let's just say it's just $1.50 if I go anything over this amount. Well, now you notice where's the kind of optimal point, or where's the win maximizing point going to be now? Well, the reason why profits were 0 here is because this is where my marginal cost curve hit my demand curve. Or we kind of could break this down, average total costs were equal to average total revenues there. So think about now with these higher costs, my profits are going to hit 0 at a lower number of wins. So now with this luxury tax, you can see that this team, right, they're going to run out of money quicker, right? And so they're going to target a lower number of wins. So this is how like a luxury tax would work, not just like a hard salary cap, but let's say, I think the MLB, I have to look it up. Does the MLB have a luxury tax? Does anyone know off the top of their head? I believe they do. So they don't have a salary cap, but they have a luxury tax. So the luxury tax convinces some teams to, they're still going to spend all their money, but at an increased cost, that's going to translate to a lower number of optimal wins. You could imagine this, yeah.
Why does the line not go over up to the demand curve? Stop like right before it. So the soft cap.
Here?
Yeah.
Oh, so you could think about, this is really just like a threshold. You could almost like think about, it's just any point past this number of wins, that's going to translate to me spending over the cap. So it's not, you can almost think about that's not even there. There's just going to be a certain number of wins where we see the marginal cost jump, because that number of wins translates to a salary expenditure that is exactly equal to the cap. So any point past that, I'm going to have to spend over the cap and incur this additional luxury tax cost.
Okay. And then also, when do you know when to make the second marginal cost?
Yeah. So if we're talking about with like if we're talking about putting actual like functional forms to this, it gets a little bit more difficult, but you can almost think about it as this isn't perfect, but you can think about it this way. That second marginal cost was the first marginal cost plus whatever that tax rate is. That's one way to think about it. It's not perfect because the tax is on, well, yeah, we can think about the difference between the value of the tax there, right? Because now I'm not spending for each additional win. It's going to be whatever my expenditure was before, plus this additional kind of tax. It's just that the tax rate, because in practice, it does vary with how much I'm spending over, the model will get more complicated. But if I just had one luxury tax, or if you spend over $100 million, this is the amount you pay, then this is how we can think of it. In practice, there's actually going to be like, as I keep spending, there's like well, here's the number of wins that translates to being more than 5 million over. Here's the number of wins that translates to being more than 10 million over the salary cap. And we would actually have like steps. The marginal cost function would almost step up as we spend more and more money if we were trying to really draw what the exact rule is in the NBA right now, right? Because the amount of the tax varies with how much I'm spending. I think it's even more complicated when you have repeat offenders, but the general idea is that these luxury tax are going to try to force teams to target a lower number of additional wins. Okay. Oh, I know what I want to point out. But one thing that's, if I don't set these caps low enough and I start the luxury tax low, like notice here, even though I got these large market teams to target a lower number of wins, I still haven't like pushed them nearly low enough to be what their number of targeted wins would be if they were profit maximizing. So these large market teams, even with the luxury tax, they're still going to spend over the cap here, right? Like they still continue to spend money past the number of wins that translated to whatever that soft cap salary expenditure was. So they're still going to spend over the cap. It's just that they're not going to spend. They're still going to spend as much over. It's just now they can't obtain as much quality, right? Because now each unit of talent is costing them more than just the dollar, right? It's $1.50 or $1.75 or whatever those steps end up being. Okay. Any other questions on this before we keep moving? All right, so I wanted to get through that. Let's see where we're at. I might jump around a little bit here. Yeah.
So like the luxury tax, so even though it does add that tax, like it's not completely, so like you have
Mhm.
But like, someone was extremely low.
Well, here, remember in the NBA, they anticipated that and say, like, even if you're spending over the luxury tax, like, there's a limit where where it stops, right? But, oops, in Major League Baseball, right? If we just say the luxury tax starts at 195 million, there's currently six, or I think this was a little bit old, yes, 2016. There was 6 teams in 2016 that exceeded this amount. It's going to be all large market teams. I mean, Detroit might be surprising, but like Detroit is still a very large city and has a very large metro area. These other teams, Chicago, San Francisco, Boston, LA, these are, we probably could have guessed at least 4 of these, which of these teams would be, right? And so if I just institute a luxury tax and I've got really rich owners that are in really large markets, what are they going to do? They're just going to keep spending. They don't care if every dollar now is, if every dollar I would have spent before, now it's $2. They don't care, right? Like this is the idea that I can limit their behaviors to a degree, but they're still going to spend past that cap. Yeah. So it's not, if we don't put like a hard cap and we just say the luxury tax starts here, but spend after that as much as you want, we're going to see that, the teams that had that face that higher demand curve or have more resources are still going to spend where profits are zero, right? It's just that it's going to hit a lower number of wins now because the cost to getting those wins is higher with this luxury tax. Is that what you were kind of getting at? Yeah. And then they have you can kind of see in Major League Baseball, this really plays out because they have the same sort of thing the NBA does where the amount that you have to pay, the luxury tax goes up as you repeated offenses. So what is it here? So yeah, for them, the luxury tax also, let's compare this, right? $1 to $1.50. That's like a 50% tax, like whatever the value was. If it was $1, I had to pay 50% tax of that, so 50 cents. Notice their jumps are like a little bit lower, so 22.5 and then only 30. So this is like 22 cents on the dollar, 30 cents on every dollar, 40, 50, right? So even if I so first offense, second, third, so fourth offense, I'm still not even paying as high a luxury tax as just barely an NBA team that just barely goes over, right? So they're not really trying to disincentivize it too much. And what's interesting is, they probably could extract more money from these large markets. So if you looked at the data, New York and Boston, in 2016, they currently had a streak of going over the cap and paying a luxury tax 13 and 8 years. Right? So they're just like, okay, yeah, we're just going to keep paying that 50% luxury tax. It's still profitable for us. We're in a large enough market to where that makes sense. Okay. We already talked about, I kind of give you kind of this idea about why we see these teams spend over the cap, right? I kind of already gave you that model. So I went a little bit out of order here. This blank slide probably could have been a little bit earlier, but sometimes when I get drawn here, I just like to kind of keep going. So let me think about where we're at here. So I want to have a good chunk of time for that reverse draft. So I will do that in next class. But we can kind of end today because this is kind of interesting. I might open with that, but we'll do schedule adjustments. So I think that I'm a decent sports fan. And then honestly, over the last however many years I've taught this course, I've realized I didn't know a lot of things. So I mean, I can be presented an issue and think through the economics of it, but it's I don't know all of the rules and all of the, So one thing that is interesting. So another way that leagues can try to improve competitive balance, and this is to me, if you were a true, I guess how much equality or inequality aversion you have depends on how you would feel about this. But one thing that the NFL does is every year, so go back not to this last football season, but the season before, they'll look at the win-loss records and they'll look at the placing within each division, right? So each conference, right, has this, 3 divisions or 4 divisions in NFL. And they look at the placing within those divisions. Well, divisional teams, right, they play each other every single year, right? And they play each other twice, right? You're in the same region, and so they think that they can drive more demand for those games, and you kind of build up these rivalry games that can, command higher demand in the future. But you also play outside your division as well and outside the conference. So 2 games for each team are played outside the division, but they're still in the same conference. Right? And so what they do is they look at their divisional finish and they would say, okay, the NFC West and the NFC East, those 2 divisions, we're gonna have some cross divisional games between these 2 divisions. However, we want to make sure that these games are pretty balanced, right? Because we think that fans care about competitive balance, or they care about outcome uncertainty. So what they do is they match up the teams from those divisions to play the person that was in the other division, but in the same position the prior year. So if we both finished 3rd the year before, now when our divisions play each other, we'll play the 3rd, like all the positions will be matched up. So that way we're getting the best team in the NFC, West against the best team in the NFC East, and the worst team in the NFC West to play the worst team in the NFC East. So we're getting more games that are balanced there, all right? And we hope that drives up revenue. It also helps kind of decrease the gap in wins, right? If we're putting up, if we had did it reverse, right? The best team in each division plays the worst team in the other. Well, now we're really going to drive up those higher quality teams' number of wins. Well, at least here that kind of help negates that a little bit, right? At least these lower quality teams have a chance to win the games, the non-divisional games here. Now you could argue, like, to me, this is definitely going to help with competitive balance, right? I mean, this is there's no argument about that, but it does seem a little unfair if you're really thinking about, like, you've got a rule where you're guaranteeing it's going to be harder for one team to win as many games. A little bit of an issue with that in just terms of fairness, but they are also trying to generate money, and trying to get these games that have less certain outcomes, right? By having teams that are of more similar quality play each other, that just guarantees you may be able to generate more revenue from those games. Or think about it this way. Let's say I just went random, and then it happens that the best team in each division, when they play their non-divisional games, plays the worst team in the other. It just happened to be that way. Well, that game isn't going to generate a lot of interest from either side, right? And so you've got 2 games that really aren't generating a lot of revenue. Like, the outcomes are pretty certain in both of them. However, if I go to what the rule they actually use, well, now I've got the 2 worst teams playing each other. Well, okay, it's still not going to generate a lot of interest. Like, they're low quality teams, but at least, like, I'm not sure who's going to win that game. Maybe it's, so maybe I lose a little bit on that because it's just 2 low quality teams. It doesn't matter that it's now a more balanced matchup. They're just low quality teams. So I'm losing out a little bit on that game, but by having the best quality teams play each other, I'm generating a lot of buzz, increasing demand a lot for this game. I'm generating a lot more revenue. So it's likely that I'll lose a little bit out on that lower quality matching, but I'm making up for it, and making even more than that from this higher quality matching that I have. So kind of an interesting thing, other than competitive balance, I can't imagine an argument. I don't know if the NFL ever said why they made this rule, but right, if we're just talking about in terms of trying to improve competitive balance in order to increase revenues, that seems to be like the only explanation to me. I don't think there's like a fairness issue or anything that we could argue here. Yeah.
I would agree with the fairness issue.
Huh?
Say you have one division that's just like you have one team just crushing everything, while the other division they're kind of tied. So it's like you have one, like, the best on each, 15 wins versus 12, and then the second best is like 8 wins versus 11 wins.
Yeah. So I guess this rule, though, if you just let it be random, that would still be an issue, right? Like, if it was just random assignment of like who played who, you would still have like a pretty unfair, like if you had divisional quality imbalances. I would actually think the fairness argument, the one thing that I can think of is that it ensures that if you're in the difficult division, it's more likely you can keep up with the higher. So let's use your example, right? So you've got 2 divisions very imbalanced, right? One has like 4 playoff teams, the other has like 4 teams almost below 500. Well, at least when you do this divisional matchup, you give the second highest quality team in the good division, the opportunity to, right, they're facing a lower quality opponent than the highest quality person in their division. So maybe you're getting a little bit more of a quality even at the top of your divisions as well, even if you had those like gross imbalances across divisions. But yeah, no, you're definitely thinking about that. Any other questions or comments on this before we end class? All right, so I'll put up an online quiz when I get back to my office. I'll also put up the reading that we'll go over on Thursday. It'll be talking about reverse draft order, since we'll be talking about that topic. That'll be the kind of reading I use. And that online quiz will be due before we start class on Thursday. Okay. Other than that, I will see you guys on Thursday.